Welcome to my channel. Do well to subscribe and like. Thank you. Hello, I go by the name Eric Sampson, a student of Ghana Telecom University. Today, I'm presenting on a component called Multiplexer, a key building block in computer architecture. Let's elaborate on how it works using this chart displayed on the screen. One may ask, what is a multiplexer? Well, a multiplexer, often called a MUX, is like a smart switch that selects one of several input signals and forwards it to a single output line. Think of it as a funnel where you have multiple input streams, but only one stream makes it out the other end, based on selection single. Interpreting the diagram, the select lines which are S0 and S1. These are the control bits determining which input is selected. Since there are two select lines S0 and S1, this is a 4-to-1 MUX. Meaning it has 4 inputs and 1 output. The binary combinations of S0 and S1 map to the inputs. S1 equals 0, S0 equals 0 right pointing arrow input 1 0. S1 equals 0, S0 equals 0 right pointing arrow input 1 1. S1 equals 1, S0 equals 0 right pointing arrow input 1 2. S1 equals 1, S0 equals 1 right pointing arrow input 1 3. Hope this makes a clear understanding. Let's see how it works with example. The multiplexer continuously checks S0 and S1. Example, if S0 equals 1 and S1 equals 0, the output equals 1 1. If S0 equals 1 and S1 equals 1, the output equals 1 3. Did you know that multiplexers are fundamental components in both CPU architectures and Wi-Fi communication, serving as data selectors to optimize performance and efficiency? Here's how they're applied in each context. Multiplexers in CPUs. In a CPU, multiplexers are used to route data and control signals efficiently. Key applications include instruction and data routing, register selection. CPUs have multiple registers, example, R0, R1, R2. A MUX selects which register's data is sent to the ALU, arithmetic logic unit. Example, if S0 equals 0, S1 equals 0 right pointing arrow select R0. If S0 equals 1, S1 equals 0 right pointing arrow select R1. Now, let's talk about multiplexes in Wi-Fi, wireless communication. In Wi-Fi systems, multiplexer manage signal routing, frequency selection, and data transmission. Key uses include the following: frequency band selection, 2.4 GHz versus 5 GHz. Modern Wi-Fi routers support dual band, 2.4 GHz and 5 GHz. MUX switches between these frequencies based on signal strength. S0 equals low right pointing arrow 2.4 GHz, S1 equals high right pointing arrow 5 GHz. Interference avoidance. In conclusion, multiplexer selects one input from multiple sources and sends it to the output. It uses control signals to determine which input is chosen. It simplifies complex wiring and improves system speed. Multiplexers are essential for modern digital systems to function smoothly. Thank you for watching.